Let us now solve problems about the vector product or the cross product of 2 and 3 vectors. Number 1. Given two vectors L equals 5.00 kilometers north and M equals 8.00 kilometers 30.0 degrees west of south. What is the magnitude of the vector product L cross M? So in this problem, we are given two vectors L and M. What is the magnitude of L cross M? So what is the formula used to find the magnitude of the two vectors like L and M? So we have this formula for the magnitude L cross M. So this is going to be the absolute value symbol. It represents the magnitude of the vector L cross M. It is simply equal to the magnitude of vector L times M, where M is the magnitude of vector M, times sine theta, where theta is the angle between L and M. Now let's look at the directions of the two vectors L and M. So note that L is directed upward. The magnitude of 5.00 kilometers, it's towards north. And the second vector, vector M, lies in quadrant number 3, the third quadrant. So this angle is equal to 30 degrees because it says here that M has a magnitude of 8.00 kilometers at an angle of 30.0 degrees west of south. So this is going to be from south to west. So this is 30 degrees. Now since theta is the angle between L and M, we need to know this angle. So this is going to be 60 degrees because this is equal to 90 degrees. So this angle here, 90 degrees minus 30 degrees. That's why we have 60. Then 60 plus 90, it gives us an angle theta equal to 150 degrees. I repeat, 150 degrees is 90 degrees plus 60 degrees. That's why we can write the magnitude L cross M to be equal to 5.00 kilometers for L magnitude, 8.00 kilometers for M magnitude, times sine of the angle between them, we have 150 degrees. And then multiply the three of them, sine of 150 is equal to 1/2 or 0.5. It gives us a magnitude equal to 20.0 square kilometers. Number 2. We are given three vectors. A equals 6i hat minus 3k hat. So vector B is I hat plus 5j hat minus k hat. And the third vector, C, is equal to j hat minus 2k hat. Determine A cross B and its magnitude. What is B cross E? What is B cross A equal to? And its magnitude. What is C cross A cross B? And what is its magnitude? Okay, let us now begin with the first question. So finding the cross product of the two vectors A and B. Okay, one way of finding the cross product of the two vectors A and B is to express the cross product in determinant form. Okay, we can solve A cross B using this method, expressing A cross B in determinant form. That's why we have on top, we have I hat, j hat, and k hat. Then followed by the components of A, because from A cross B. So we begin with A, we have the components are AX, AY, and AZ. Then followed by vector B, we have BX, BY, and BZ. Okay? Now, let us begin with I hat. So we have now I hat here equals I hat. And then after writing I hat, we need to remove the X components. These are aligned vertically with I hat, so we need to remove this one, X components. And then what remained are, if you look at this bar here, what remained are AY and BY. So these are the remaining components, AY and BY, AZ, BZ. So we begin with plus I hat, then minus J hat, then plus K hat. So that's the pattern when using this method in determinant form. So we have plus, minus, and then plus. So we are done with I hat, then followed by minus J hat. We have again with J hat, so we remove the y components, we have ay and by, so that we have now only ax bx, we have ax bx, and az bc. Then lastly, we have plus k hat, so plus k hat here, so we remove az bc, and that's why we only have ax bx, we have ax bx, and ay by, so we have ay by. So after that, we are going to multiply. But first, copy I hat, and then j hat and k hat, then put the numbers. We have I, j, k, we have ax is 6.0, then we have 0 for the y component of a, and then minus 3 for the z component. So these are the components of a, ax, ay, and az. How about for vector b? So the components are 1, 5, and minus 1. 1, 5, and minus 1. It is equal to, again, let's begin with I hat. So I hat with I hat, so we remove this one, the x components. So that's why we only have 0 and 5 here, 0 and 5, and minus 3 and minus 1. Followed by minus j hat. So for j hat, so we remove 0 and 5. So what remained are 6 and 1, then minus 3 and minus 1. Then plus k hat, so we have k hat here, so we remove minus 3 and minus 1. That's why we only have 6 and 1, and then 0 and 5. Okay, so after that, we begin with I hat again, so we have I hat here, and then what we are going to do is to multiply the four of them diagonally. For example, we can multiply 0 times negative 1. So 0 times negative 1, then minus 5 times minus 3. Okay, so that's why we have 0 times negative 1. Let's begin here in this in finding the product. Okay, in this direction, we have 0 times negative 1, then minus, we have 5 times negative 3. Then minus j hat, again the same process. We have 6 times negative 1, we have 6 times negative 1, and then minus we have 1 times negative 3. Then lastly, we have plus k hat. Then multiply diagonally, we have beginning in this direction, we have 6 times 5, then followed by minus, then 1 times 0, we have 1 times 0. Okay, so that's why we have now, we have I hat, then we have 0 times negative 1 is 0, then we have negative 5 times minus 3 is plus 15, then minus j hat, we have 6 times negative 1 is minus 6, or negative 6, plus we have negative 1 times negative 3 is still 3 or plus 3, then plus k hat, we have 6 times 5, we have 30, then minus 1 times 0 is equal to 0. That's why the cross product now is equal to 15 I hat, then plus 3j hat, we have negative 6 plus 3 is minus 3, then there's a negative sign outside, that's why we have positive 3j hat, then plus 30k hat. Okay, this is the result when we express the cross product in determinant form. A cross B equals 15I hat plus 3j hat plus 30k hat. Let us try another method. So using the distributive property of multiplication. So just multiply, you have to distribute the numbers. So for example, A cross B. So with A is 6I hat is given, is minus 3k hat, and then cross member B is I hat plus 5j hat minus k hat. So when we multiply, so we begin with, for example, with number 6, we have 6 times 1. Okay, 6 times 1. And then I hat cross I hat. Let's look at the solution. We have 6 times 1, beginning with number 6, and then times 1 here on the other side. We have 6 times 1, and we have I hat cross I hat. Then plus we have 6 times 5. 6 times 5, then we have I hat cross j hat. Okay, now you cannot interchange I and j. It is always I cross j because you begin with I cross j, I then j. You cannot make this j cross I because I cross j and j cross I are not equal. Okay, then we are done with 6 and 5. Next we have 6 and negative 1. We have plus 6 times negative 1, then we have I hat cross k hat. So we have I hat cross k hat. Then we are done with 6, so let's proceed to negative 3. So plus We have negative 3. Okay, 3 times 1 here. Then we have k hat cross I hat. We have k cross I. Then plus, we have negative 3 times 5. Okay, negative 3 times 5. And then we have k cross j. So we have k hat cross j hat. And then lastly, we have negative 3 times negative 1. So plus negative 3, negative 1. Then we have k hat cross k hat. Okay, so we have 6 times 1 is equal to 6. But what is I hat cross I hat? So this is the cross product of a vector I hat by itself, by I hat. Then note that the vector product of a vector by itself is always equal to 0. Okay, you can show that by using the formula A cross B magnitude equals AB sine theta. So for example here, this is I hat, this is I hat also. So A has a magnitude equal to 1. We have A times B, we have 1 times 1 because these are unit vectors. They have magnitude of 1. So 1 times 1 and times sine of the angle between I hat and I hat is equal to 0 because they have the same direction. So sine of 0 is 0. That's why this is going to be 0. Now, so 6 times 0, then plus, we have 6 times 5 is 30. Now the problem is, what is I hat cross j hat? So to find I hat cross j hat, you can use the right hand rule or you can use this method. So in this method, when we go clockwise, it means that the cross product is going to be positive. If you go counterclockwise in finding the cross product, the result is negative. For example, I hat cross j hat, that's counterclockwise, clockwise, I hat cross j hat is equal to k hat. Then j hat cross k hat is I hat. And k hat cross I hat is j hat. Okay? But if you go counterclockwise like I hat cross k hat, the result is negative j hat. And k hat cross j hat, we go counterclockwise again, and the result is minus I hat. So therefore, we have now 6 times 5 is 30, and we have I hat cross j hat, so we have I hat cross j hat, so we go clockwise, so we have now k hat. So we have 30 k hat. And plus, we have 6 times negative 1 is negative 6. Then we have I hat cross k hat, so we have I, so we cannot go clockwise because the next vector is j, so we need to go counterclockwise. So we have I hat cross k hat is minus j hat. So we have negative 6 times negative j, we have positive or plus 6j hat. So then plus negative 3 times 1 is equal to negative 3. And we have what is k cross I? So we have k cross I is clockwise equals j. We have minus 3j hat. Then how about this one? We have negative 3 times 5 is negative 15. What is k cross j equal to? So k hat cross j hat, we have k. We cannot go clockwise because this is I hat. We have k cross j is equal to minus I. So we have plus 15 I hat. And lastly, we have negative 3 times negative 1 is 3. Then k hat cross k hat is equal to 0. This is the vector product of a vector by itself is 0. And then rearrange. So we have beginning with I hat. We have now 15 I hat. Then plus we have 3j hat plus 30 k hat. Okay, this is the same as our previous slide result, A cross B. Okay, how about the magnitude of A cross B? If we know A cross B, because A cross B is equal to 15 I hat plus 3j hat, I mean 30k hat, we have 15 I hat plus 3j hat plus 30k hat, then we can find its magnitude, so assuming that we let M to be equal to A cross B. So its magnitude is M equals the square root of mx squared plus my squared plus mz squared. So just square the three of them. 15 squared, so plus 3 squared plus 30 squared, and then get the square root. So we have 15 plus 3 plus 30, we have squared, equals, we are going to add them, we have square root of 1134, which is equal to 33.7. That's the magnitude of A cross B. How about the magnitude of B cross A? So if we know B cross A, we can easily, A cross B, we can easily calculate B cross A because B cross A is just simply equal to the negative of A cross B, or A cross B equals the negative of B cross A. So meaning these two vectors have the same magnitude and are opposite in direction because of the negative sign. Okay, so B cross A equals negative, this is negative, and multiply it by the cross product A cross B. We have this result for A cross B. We have 15 I hat plus 3j hat plus 30k hat times negative 1. So just distribute the negative sign, negative 1. So we have negative 15 I hat minus 3j hat minus 30k hat. So therefore, the magnitude is also equal to 33.7. So we have negative 15 squared, so plus minus 3 squared, plus minus 30 squared. Although these are negative numbers, but we have this parenthesis and then you square, and then square, so the result is positive. So note again that the magnitude of a vector is always positive. It can never be negative. So it is equal to 33.7. Same as this. Okay. So the third is to determine the cross product. We have C cross A cross B or C cross M. So where M is equal to the result A cross B. So we have now where C is equal to J hat minus 2K hat is given in the problem. Then M is 15 I hat plus 3J hat plus 30K hat. So do the same process. So we have C cross M is equal to, we have express the cross product in determinant form. We have on top, we have I hat, J hat, and K hat. So followed by the components of vector C, because we are asked to find C cross A, C cross M, okay, not M cross C. If this is going to be M cross C, then we begin with 15, the components of M. That's why we have vector C first, then cross M. So that's why we have the components of vector C are 0, 1, and minus 2. For vector M, we have 15, 3, and 30. We have 15, 3, and 30. Okay, then we have I hat. Then we need to remove this one. Again, remember the process. So what remains are 1 and 3 and minus 2 and 30. So 1, 3, minus 2 and 30. Then followed by minus J hat. So minus J hat, so we remove 1 and 3. We have 0, 15, minus 2 and 30. 0, 15, minus 2 and 30. Then plus K hat. We have K hat, so remove this one, minus 2 and 30. So we have only 0, 15, and 1, 3. Okay, and then we multiply. We have I hat. So beginning here in this direction, we have 1 times 30. And then minus, always minus 3 times negative 2. Then minus J hat, we have minus J hat. So we have 0 times 30 and then minus 15 times negative 2. Then plus K hat, so we have 0 times 3. 0 times 3 and then minus 15 times 1. Okay, so we have now, this is 30 plus 6. We have negative 3, negative 2 is, the product is 6. So we have 30 plus 6. Then we have minus J hat, this is 0. 0, we have plus 30. Negative times negative, 2 times 15 is 30. Plus K hat, so we have 0 minus 15. So what is the cross product? We have C cross M is 36 I hat and minus 30 J hat minus 15 K hat. So the magnitude of C cross M. So remember this result. So we have square root of 36 squared minus or plus minus 30 squared plus negative 15 squared. So just take the square root of the squared of these numbers, the sum of the squares. So that is equal to this is equal to this amount. This is equal to 900. This is equal to 225. So just add all of them. We have square root of 2,421 and is equal to 49.2. The magnitude of the cross product C cross M. Number 3. The magnitude of the vector product of two vectors L and M is 45.0. If vector M is 10.0 I hat and 5.00 k hat, and if the angle between them is 50.0 degrees, so find the magnitude of vector L. What is L equal to? So first, let us write what are given. So we are given L cross M, the magnitude, is equal to 45.0, and vector M is given also. We have these numbers, unit vectors. You have 10 I hat minus 5 k hat. Then the angle is also given. You have 50.0 degrees between L and M. So find the magnitude of L. We can easily find this one because we have the formula L cross M, magnitude equals Lm sine theta. To find L, so we have L equals L cross M over M and sine theta. L cross M is 45 over M, so the magnitude is not given, but we can calculate this one using this vector M, okay, times sine of the angle 50 degrees. So what is M magnitude? It is simply equal to, remember, this is 10 squared plus 5 squared, and then get the square root. It gives us mx squared. So remember again, m is 10.0 I hat minus 5.0 j hat, k hat. So m is mx squared plus my squared plus mc squared. And there's no y component here, so this is going to be 0. Mx is 10, mz is negative 5. So we have the numbers 10 squared plus 0 squared plus negative 5 squared. So we have 100. This is 25, so we have square root of 125, which is equal to 5.00. Then going back to the formula L equals L cross M over M sine theta. Let us now put the numbers. L cross M is a magnitude of 45. Then M is 5 from this result in sine of 50 degrees. So the product of 5 and sine of 50 is 3.83. Then 45 over 3.83. So L has a magnitude of 11.7. Number 4. The magnitude of the cross product of two vectors, perpendicular vectors, P and Q, is 50.0. If the magnitude of Q is twice the magnitude of P, what are the values of these magnitudes? What is the value of P equal to its magnitude? What is the magnitude of Q? Okay, so again, let's look at what are the given parameters. We have P cross Q is equal to 50, its magnitude. Then again, it is stated here that if the magnitude of Q, so Q is twice P, we have Q equals twice of P, we have Q equals 2P. And then what is the value of Q? What is the value of P equal to? So what we need is to go back to the formula. We have P cross Q equals PQ sine theta, where theta is equal to 90 degrees because the two vectors are perpendicular. So we have P cross Q is 50. That is P, so just copy P. But we know Q, so we have Q is twice of 2P and sine of 90 degrees. But sine of 90 degrees is equal to 1. Okay, so we have now 50 equals copy P, and Q is 2P, we have sine of 90 is equal to 1. So 50 equals 2P squared, so therefore we have P squared equals 25. So P is simply equal to square root of 25, therefore equal to 5.00. And from this equation, we have Q is twice 2P, we expect Q to be equal to 10. So we have Q equals 2 times 5, it gives us 10. So the magnitudes of vector P and Q, we have 5 and 10. Number 5. Vector A has a magnitude of 12, while vector B is equal to negative 2.5 I hat plus 4.10 j hat plus 7.00 k hat. If the cross product of these vectors is 6.20 j hat minus 8.30 k hat, what is the angle between the two of them? What is the angle between A and B? So let's look at again what are given. So we are given A, its magnitude. You can write A here, there's no arrow on top, or this one. Its magnitude is equal to 12. So vector B is given. And then the cross product A cross B is also given. We have these results here. 6.20 minus 8.30, it's given. So if you want to find the angles, again we have the formula A cross B equals AB sine theta. What is the value of theta? So we have sine theta equals A cross B over AB. Okay, A is the magnitude of vector A, B is the magnitude of vector B. So theta is equal to sine inverse of A cross B over AB. So again, A cross B has a magnitude equal to what? We need to use this equation here. So we have 6.2 squared plus negative 8.3 squared. And then square root, that's how we find the magnitude. A is given, we have 12. How about B? So B is equal to square root of negative 2 squared plus 4 squared, 4.1 squared plus 7 squared, and then square root. Okay? So A cross B is equal to, its magnitude is equal to, we have 6.2 squared plus negative 8.3 squared. So we have square root of 107.33. We're going to add the two of them. And then it gives us a magnitude of 10.36. And lastly, we need to know what is B magnitude. So we have B is square root of negative 2.5 squared. This is 2.5 squared plus, we have 4.1 squared plus 7 squared. And then square root, we have 72.06. So square root of that is 8.5. So to find theta, so we go back to the formula. Theta equals sine inverse of A cross B over AB. So put the numbers. A cross B is 10.36. So based on this result, then we have A is 12 and B is equal to 8.5. So then the product of 12 and 8.5 is 102. Then divide 10.36 over 102 gives us 0.1016. And then sine inverse of that number, it gives us theta equal to 5.53 degrees.